Welcome protein coders, let's build some coding muscles. So today we are gonna do a question, number of connected components and provinces, which will be based on our previous studied concepts BFS and DFS. So let's see here. In the first part, this is a graph, okay? Don't think like it has two parts, so there are two graphs. No, it has two components, okay? Similarly, in the third graph, you can see there are four components, okay? Don't get confused. It is a single complete graph. And today we have to find number of components in the given graph. So in first, you can see there are two components, right? We can reach from 1 to 2, 2 to 3, right? And 4 and 5. Similarly, in second one, we have a single component. In third one, we have 1, 2, 3, 4 separately 4 components, right? And remember, it is an undirected graph, okay? Now let's see how we're gonna approach this problem. So in this graph, let's say we can start from any node. We started from 1, we mark it as visited, and what we will do, we will perform DFS. Okay, so from 1 we have only one neighbor 0, so we'll go to 0. We will mark 0 as visited in our visited array. Then from 0 we have 2 as unvisited neighbor, so we'll go to 2, right? And 2 doesn't have any unvisited neighbor, so it will trace back. So our first DFS call got completed. Now what we will do, we will choose another node which is not visited and again call the DFS in similar fashion. Okay, if there are more components to this graph, then we will do the same. Okay, now see, observe, we have called DFS for 2 times. So what we can say, what is the observation? The number of times we called DFS, right? The number of times we done the traversal is equals to the number of provinces or components. Okay, so this is the main thing. I hope you understood this. Now let's see the code. How are we going to do it? It's very simple. We will just run a for loop for each node. Okay, here I'm starting like I is going from 0 to n, like 0, 1, 2, 3, 4. Okay, and what we're going to do is, for every node, if it is not visited, we will call DFS. So let's take a integer count, assign it to 0, and we will check if I is not visited. If visited of I is 0, then what we will do, we will call DFS. Call DFS, and DFS, what we send, the node, the starting node, the visited array, and the adjacency list, as we studied in our previous video. Okay, if you have any doubt in DFS and BFS, I would suggest you to see the previous DFS and BFS video. It's very short and concise and crisp. Okay, so here, then what else we will do is, we will increase the counter. Okay, so in first traversal, it will count the component, and again when I reaches 3, it will see 3 is not visited, so it will again do the DFS. It will again call the DFS, and we have count as 2, and finally we will return the count. And here instead of DFS, we can also use BFS, right? Because it's very similar, we are just traversing the graph. Okay, traversal can be done in both ways, DFS and BFS. It's a LeetCode question. There you will find adjacency list is not there, they have a adjacency matrix. So how to do it, it's very simple. You can just see the code also. I will attach it into the description. Okay, and now let's revise what we have studied today. First thing first, we have studied about the graphs. Okay, there can be various components to it. Then we studied about the how we're gonna count the components, the number of DFS calls which we do in the traversal will be equals to the number of provinces, right? We will call the DFS for every node. If the node is not visited, we will call DFS for it. Okay, so that's all from my side. If you don't understand, don't subscribe, don't like, but if you do, please support. Keep smiling, keep practicing.